In order to do this lesson about parallel and perpendicular lines, you just have to know two rules about parallel slopes and perpendicular slopes. So two lines that are in the same plane that never intersect are called parallel. Hopefully you already knew that. Now, plane is a fancy geometric phrase for a flat surface. You'll learn about that in geometry. Two lines are parallel if and only if they have the same slope. And that's all you need to know about parallel lines. So as we look at the picture in example 1, let's figure out which lines are parallel. So we take our 2 points, right? Each line conveniently give you 2 points, and you just count what their slope is. So the blue line is down 1, right, what is that, 5? So that's the slope of the blue line. The red line has a slope of down 1, right, 4, so that's not the same. The green line, we now just have to see which line it matches. Is it 1/5 or 1/4? And it's down 1, right 5. So it actually matches the blue. Now, the way that you say it is you would say the blue and green lines are parallel. But here's how you finish it with the because. You don't say because they never touch, because that's what you learned in 5th grade. What you say now in algebra is because they have the same slope. So don't say because they never touch. That's an elementary school definition. In this next example, we're going to combine our skills from knowing about parallel lines, but also from the point slope formula. So in example 2, they give us a point, and they tell us that they want it to be parallel to this line. Now, parallel means that it has the same slope, so the slope m is still 2. The question is, what's the intercept? So you can do this two ways. One is to use the y equals mx plus b formula, and the other is to use the the point slope formula that we learned last lesson. So the way that you would do it using method 1 is you find the slope, which we just calculated, that's 2, right? You just look at the equation, that's 2 because it's parallel. And then what you do is you take your formula, y equals mx plus b, but instead of x and y and m, you put what you know. So I know that the slope is 2. But I also know a point, right? This is a point on the line. So I can plug that in, and I can say -4 is y, and 5 is x, and then you just calculate. So you get b is -14, so it would be y equals 2x minus 14. Another way to do it would be to use our formula from last lesson, the point slope formula. So let me show you that one. The slope is still the same. The slope is still 2 because we're parallel. But what you can do is you can plug this in to x1 and y1 into the point slope formula. So you get y plus 4 equals 2 times x minus 5. That's the point slope formula. So then you just simplify that, and you end up getting the exact same thing. It's just a question of which one you like better. The rule about perpendicular lines is a little bit more complicated. Perpendicular lines, as you know, form right angles. But the reason that they form right angles is because their slopes are what we call opposite reciprocals. So what's an opposite reciprocal? So let's say that one slope is 3/2. The opposite reciprocal of that is -2/3. So you change the sign, right? You make it the opposite, and you flip the fraction to do the reciprocal. So that would be a pair of opposite reciprocals. If two lines had those slopes, they would end up being perpendicular. What's the opposite reciprocal of, let's say, 7? Well, that would be -1/7. Because remember, 7 is 7 over 1. So when you flip it, you become 1/7 and change the sign. What if it's already negative? What if it's like negative 4/5? So you change the sign and you flip the fraction, you get positive 5/4. So that's some example of opposite reciprocals. And then just one last note, this should visually make sense to you. Vertical lines are perpendicular to horizontal lines. In example 3, they want us to just tell which they are, parallel, perpendicular, or they might not be anything. But in order to do that, we have to easily identify the slopes. So I can easily identify that line A has a slope of 4. But I can't easily identify the other ones because they're not written in slope-intercept form. So what I'd like you to do is pause the video and get lines B and C to have the y by itself, so that way they are in slope-intercept form. Alright, so I did that and moved everything away from the y, and now what I have is that line B has a slope of negative 1/4, and line C also has a slope of negative 1/4. So I didn't really leave any room for myself to write the answer, but the answer goes something like this. B and C are parallel. And they're parallel because they have the same slope. A is perpendicular. That's the symbol for perpendicular. It's like an upside down capital T if you've never seen it before. And I'm using it because I ran out of space and also because perpendicular is kind of a long word. A is perpendicular to B and C. So A is perpendicular to B. It is also perpendicular to C because they are negative reciprocals, and B and C are parallel. All right, let's check out example 4. They want us to write the equation of a line that passes through negative 3, 1, and it's perpendicular to this equation. So if it's perpendicular, then its slope is going to be negative 2 over 1, or just negative 2. You have to flip the fraction and change the sign. This number right here, this plus 3, is actually distractor information, and we don't need it. It's just part of the original equation. So you can choose either of the two methods. I am going to practice our newest formula, which is point slope. So I'm going to do y minus 1 equals negative 2 times x plus 3. And then I just distribute. Y minus 1 equals negative 2x minus 6. When you add 1 to both sides, you get y equals negative 2x minus 5. So if you were to get out a piece of graph paper, this original equation would be perpendicular to this equation, and one way that you can notice is that they have negative reciprocal slopes. Alright, let's check out example 5. The position of a helicopter search and rescue crew is shown on the graph. That's the green line. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. So we're trying to end up making this a right angle. We have to write the equation that represents the path. So they don't give us anything other than this picture. So let's find the equation of this picture. I can see the slope, I can calculate it. It doesn't have a friendly intercept, so I'm not going to kind of worry about that, but I am going to find two friendly points. It goes through 4, 1 right here, and it also goes through 1, 3. So I can use those 2 points to find the slope. So let's do 1 minus 3 over 4 minus 1, and that gives me a slope of negative 2/3. And now if I want to be perpendicular to that line, then the slope that I need to do is actually going to be 3 over positive 2. So this is the slope, this is the perpendicular slope that I'm going to use in my formula. Here we go. Y minus 4 equals negative, wrong slope, 3/2 times x minus 14. And I used this point that was x1 and y1. So now we just keep going, finish it up. So we have y minus 4 equals 3 halves x. 3 halves times 14 is 21, so minus 21. And then you add 4 to both sides, you get 3 halves x minus 17. So that's the equation that represents the path of the helicopter. If you have any questions, write them down and ask me when you come to class.